All right, so again, this is labeled, this piece of paper you have is labeled Z-Scores Introduction, but it's replacing Z-Scores Part 1 in our notes packet. Question 1 said use the normal curve to answer questions below. And this is a review. This is what we know how to do so far, right? We know how to find percentages on the actual intervals. So at 0 standard deviations, 1, 2, and 3 standard deviations away. And so we had those percentages that we added in last class, right? So we know that this section's 34, 34, 13.5, 2.5, so on and so forth. So on A, what percentage of data falls below 110 or 2 standard deviations? That was that 97.5%. B, what percentage falls at or below 100? So here down was 84%. C, what percentage falls at 90 or below, which that's 0 standard deviations is 50%. And I could ask you at 90 or above, and of course that would be 50%. If I asked you above A or above B, it would be the remainder of that from 100, of course, because it's 100% in the curve, and that's really important aspect for us to think about. And on D, approximately what percentage falls at or below 80, which was 16%, and at or below 70 is that little tail of 2.5%. And so moving on here, when we want to talk about, when you want to know what a percentile score is that doesn't lie perfect on one of these tick marks, we will have to calculate what we call a Z-score. Z-scores come from calculating the exact area under the curve, and as I shared with you last time, that involves calculus, finding the area under a curve. And so we have something called a Z-score table that I'll pass out here in just a little bit, and that'll help us find these exact numbers because we're not going to learn how to do calculus this year, okay? A Z-score measurement A Z-score is a measurement of how far away each score is away from the mean in terms of standard deviation. So let's look at example number 2. Okay, it says use the normal curve from question 1 to answer these below. So because of the symmetricness here, and that each of these are, the standard deviation is 10. The mean is 90, the standard deviation is 10. I would like you to take 2 minutes here and give it your best guess at how far away these numbers shall be. Okay, for instance, on A, it says, what is the Z-score for 95? So how far away, the Z-score is, again, in terms of standard deviations. So if I ask you first of all about, let's jump to B. It says, what is the Z-score for 100? How many standard deviations away was 100? 1. So its Z-score is 1. Okay, let's jump back to A. What is the Z-score for 95? How far away is 95 from 90? 5 points away. But if 100 is a Z-score of 1, what do you think a Z-score for 95 might be? 0.5. Okay, so Z equals 0.5 or Z equals 1. Go ahead and try C, D, E, and F. All right, let's go ahead and see where we're at here. On C, of course, a z-score here for 105 equals 1.5, and a z-score for 110 would be 2. Standard deviations away, z-score is 2. Going on to E, 85 is on the left side of the mean. And so that is going to be a negative 1/2, whereas that z-score on the right side, those were all positives. So a z-score of 75 is a negative 1.5. Now, z-scores for 72 and 103. So now we're not at those nice half increments away. So let's think about these being as tenths, right? Levi, what do you think that z-score for 72 might be?
Negative 1.8.
Negative 1.8. Good. So we're going tenths away. So then going the other direction at 103, our z-score would be 1.3. So it's a little bit abstract thinking, trying to figure out that z-score for G and H, and what does that mean? So mathematically, what is a z-score? And if you would flip the page, we'll fill this in. So there's a formula for calculating a z-score. And so the z-score always equals x minus x bar divided by standard deviation. Okay? So the z-score always equals, so whatever your observation is, right? So x is the observation, a number in the data set. X minus x bar of course is your mean, so x minus x bar divided by the standard deviation is what your z-score is. So you don't always have to draw out that normal curve, label everything. We can just simply calculate it. So then some vocabulary that goes along with that. Observations falling above the mean are always going to have positive z-scores. Observations falling below the mean are always going to have negative z-scores. Just like there are percent rules for observations falling within 1 and 2 standard deviations of the mean, there are percent rules that go along with nearly any z-score. And we're going to find those percent rules by looking at the table. Okay? And so there's a table that is produced, so you don't have to complete and calculate a calculus problem every single time. Because as we've talked about, almost every single company collects data and analyzes it. And so they have a z-score table that their statisticians would look at to find those values. Now, the table itself always tells you the percent of the data to the left. Okay, the data itself or the table always tells you the percent to the left. And I'm going to go ahead and pass out the z-score tables now for us to look at. Put your name on this piece of paper. You will get to use this z-score table on any quiz or test that we have for the rest of the year, including your final. So please don't write any problems on the edges of it or write the formula for z-scores. You just get this particular piece of paper. You have one. Gray paper sometimes. All right, so again, put your name on this z-score table up in the top corner, but don't ever write any other mathematical things on this piece of paper, okay? So let's look at how the table works. So at the top, it kind of gives you a picture of a normal curve, and it's telling you, it's reminding you, hey, these values are for the left side. So then this paper is two-sided if you haven't looked at it yet. The front side is your negative z-scores, Okay? The back of the table is your positive z-scores. Okay? So it's a 2-column paper. So let's look at a couple of problems together. So let's all find a z-score of 1.71. And let's even go negative. Negative 1.71. So how that works is you go down the left column here, and you're going to find 1.7. Negative 1.7. So it's here in the gray. And then you're going to go across until you get the hundredths place. So would you all agree that negative 1.71 would be right here where my mouse is? And I know in this video here that you'd be watching would be very blurry. There we go. I can zoom in. 1.71. So these are all in decimal form. If you wanted to say the percent, what would we have to do? Multiply by 100 or move that decimal place over 2 spots. Okay? So the percent under the curve here, if I moved it over 2 spots at negative 1.7, would be 4.36%. So think about that, what that looks like going back to a normal curve. This is the area under the curve. So this is 1 standard deviation away. 1.7 standard deviations would be way over here, right? And remember what this little piece is? That's our 2.5%. So that you can think about it and say, does this make sense? Should that be 4%? Sure, because it's just over the 2.5 range. So you can go think back to our original percentages that we all understand and see if it makes sense. Why don't you all find this one? Let's go back to my examples. Find a z-score of 0.37. So you flip your paper over and go to the positive side. 0.37. Point to it with your finger. 0.37. So we're going to be in the top column, right? 0.3 is here, and then go all the way across to 0.37. And this is the area from the z-score all the way back. So that percentage would be what? 64.43. So the first thing we're going to do, we're going to go back and practice that z-score equation. And then we're going to come back and practice the table a little bit more. So I want you all to tell me, we're going back to this problem, okay? And I want you to not think about it abstractly. So on your little half sheet, you can just write these over here in this empty space, okay? This is going to be example I and J. I want to know what's the z-score for 93 and what's the z-score for 115. And without even thinking about the chart, okay, you need to know what is your x, okay? You need to know what is your mean, and you need to know what is the standard deviation. So back to the problem, what was the mean? 90. And what was the standard deviation? 10. Okay? And so I want you to use that z-score formula, and that says that z equals what?
X minus X bar.
Divided by the standard deviation. So you have two options if you're going to be typing this into your calculator. Okay, you can just subtract that in your head and type it in as a division problem, or you can, use parentheses around the top, and then divide by your standard deviation. The third option would be subtract it, hit enter, and then hit divide. But you can't type it all in together without parentheses. Okay? So in our, what would be writing down here would be 93 minus 90 divided by 10. That is what you would be doing for the formula, right? 93 minus 90 divided by 10. We usually, if this is of course an exact, 3 divided by 10 is 0.3. The z-score table works to the nearest 100. So if I give you all a random problem, let's do that. Let's say that the mean of a data set is 143 and the standard deviation is 7. The mean of a data set is 143 and the standard deviation is 7. Tell me what is the z-score for the observation of 152? What is the z-score if your observation is 152? Okay? So as we practice z-scores today, this formula, I think, will stick pretty quickly. Okay? So it's always observation minus the mean, right? X minus X bar divided by the standard deviation. So we'd want to round this to the nearest 100 because that's what our table works out to, and that's how we would be the most accurate. So 152 minus 143 divided by 7. 1.28. Oh, I didn't get my decimal in the right spot. .285714, right? This decimal that doesn't end. What are we going to round that to? 1.29. So when we type that into our calculator, that numerator reduced to 9 divided by 7, 1.29 would be the z-score. So then if I said what percentage falls below 1.29, let's go back to our table. Find the positive side of your table. We're going to find 1.2. You find that row and go all the way over to the 0.9. Sometimes it's nice to have a ruler or another piece of paper to keep yourself lined up there. What percentage is that? 90.15%. Okay. What questions can I answer over z-score equation or z-score formula and using the table? Yep.
So then if it says falls above, you take the percent of, that's not in the equation, right? You take like 100% minus the percent it gives you.
Correct. Let's go ahead and do that. Let's take 2 minutes here and answer all of those problems there on question 3. All of you take 2 to 3 minutes and do as much as you can of question 3, and then we'll talk about those answers. So working on example 3. All right, let's go ahead and talk about what we have so far. So what percentage of the, in normal distribution, we're using our table here to find this, what percent falls below 2.9? Of course, if there's no number after that, you're going to use the 0 column there. And we're moving that over. So this is very, very small. It's 0.19%. This is way over there, okay? In a normal distribution, what percentage falls below the negative 1.5? We should have had 7.35. Would anyone like me to show where that's at on the table? Are we okay? And so that looked like 0.0735 on the table, of course. And what percent falls below 0.76? We should have got 77.64%. Are we good with that one? And then on D, I'm now asking falling above that z-score of negative 1.28. We're still going to use the z-score table and go find negative 1.28, and that was 10.03%. And then we would take 100 minus 10.03, and then we'd know that 89.97% falls above the z-score of negative 1.28. On E, what percent falls above that 0.56? Again, find 0.56 first, which is 71.23%, and subtract from 100. We're getting 28.77. And then on F, what percent falls in between? So I'm not going to subtract from 100, but I'm going to find both percentages and subtract from each other. So the z-score for that 0.45 was 89.89, and our z-score at 0.95, 60, or I'm sorry, I said that backwards. This is, of course, going to be smaller. So the 0.45 is our 67.36. The z-score of 0.95 was 82.89%, and then we subtract them from each other. So the percent between them is 15.53%. And the same practice here with G. Negative 1.93 is 2.68, and negative 1.16 is 12.3%, and subtracting those, we should have got 9.62%. Okay, so that completes this section of notes. I'm going to go ahead and pause.